Not so long ago, one of the Reddit threads provided information about the Voyager probes. In this post, an unnamed NASA staffer told the readers that the Voyager 1 probe didn't just stop transmitting the signal about its location, as claimed by NASA. The user also said that the probe registered some mysterious humming sound, which reportedly contained a message in Morse code. When they decoded the message, they recognized the sounds from the golden records played on repeat, as if someone or something found the probe and was trying to communicate. NASA has not commented on this story. The story itself is pretty mystical, just like the story of Voyagers, full of revelations and frightening discoveries. But most importantly, where did it all take place? Where the knowledge about space ends and the theories begin, beyond the heliopause. But let's start at the beginning. How did humanity come to research one of the biggest mysteries of space? And what was the status quo before this discovery? In 1977, the Voyager 2 and Voyager 1 probes left our planet, beginning their journey towards the faraway gas planets of the solar system. The mission was expected to take 4 years. However, since then, it went way beyond its original task, and now the probes explore domains that no one even hoped to reach. We should mention that initially, the main mission of the Voyagers was to study and photograph the remote planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, each. The timing of the start of the mission was not selected randomly. It took place exactly when there was a rare and unique opportunity to visit all of the furthest planets of the solar system, since they align to be relatively close to each other. This only happens every 176 years, so the scientists did everything in their power not to miss this chance. But how does it work? Essentially, the planets pass the probes from their zone of responsibility to the next planet, while remaining as close to each other as possible. At the same time, the probe set some unique records. Voyager 1 set a record as the fastest moving controlled object propelling away from Earth. Nothing ever left us quite so fast. It is also the furthest removed object created by humans. Voyager 2 has something up its sleeve too. It is the first and only probe so far to have visited all 4 giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. The probes had an additional task to study interstellar space. But what is that? To make it really simple, it's a place where the sun's influence, such as its gravitational pull, warmth, and energy, is completely absent. The place where such influence is predominant is called the heliosphere. The area where the sun's energy and gravity are present is defined as the solar system. We're yet to see if these probes can defy the heliosphere and leave the solar system. First, let's take a look at what's inside the Voyager probes. First and foremost, they're packed full of computer systems. Even though they were made back in the 1970s and your smartphone's processor is much quicker and more efficient, these systems are unique. Their main feature is that they can be reprogrammed and rewritten indefinitely, which is what scientists have been doing. What for? As the probes move further away from Earth, the number of systems needed for maintenance and task performance changes. In essence, Voyagers are like transformers, even if they're quite primitive. Depending on the task at hand, a Voyager probe can take photos, study the complex space energies, and record where it is in relation to Earth. And that's just a small part of the probe's functionality. NASA, who are in charge of the probes, disable any redundant systems to redirect the power and keep the Voyagers charged, allowing them to stay with us longer. For example, right now, the camera systems on both probes are off. The Voyagers are expected to celebrate their 50th birthday in 2027, still remaining in contact with Earth. The power system on the probes is also unique. It's similar to an ordinary car, except instead of gas, it's fueled by a radioactive element. The creators of the probes promised a 10-fold quality guarantee on all systems. Considering that the probes are now over 40 years old, you could say that promise was fulfilled. And finally, the most important part of the probe are the tools designed for space exploration, each one with a unique purpose, providing us with their own view of the cosmos. So the main mission was for the Voyagers to explore the furthest planets of the solar system. One of their primary results was supposed to be a collection of unique images of the following planets: the volcanic eruptions on Io, a satellite of Galileo, which is in turn one of Jupiter's satellites; the famous rings of Saturn, which are neither solid nor liquid, but a collection of watery ice. The strongest winds in the solar system were recorded on Neptune, reaching about 1,370 miles per hour. The famous picture of Earth from space, the legendary pale blue dot, is the furthest picture of Earth ever taken. That was the result of the Voyager's journey through the heliosphere. But what boundary did they have to overcome, and what difficulties awaited the probes? When they tried to leave the solar system, let's take a closer look at the heliosphere and the heliopause. And why? Moving beyond the boundaries of the solar system is a pretty difficult task for any object. Before the Voyager's research, any knowledge about the heliosphere could be classified as theories and assumptions. For example, it was thought to be shaped as a sphere, but the data about the speed of the solar wind, the influence of magnetic fields, and the data about its contents were unavailable to science. We also did not know where it begins or where it ends, and certainly whether or not we can go beyond it. Now, let's talk about the terms. The sphere of influence of the solar wind and the sun's gravitational pull is known as the heliosphere, and we don't know the bounds of the heliosphere yet. A place where the solar wind is balanced by the interstellar wind is the heliopause. It is not yet possible for us to comprehend the size and shape of the heliopause. The best way to envision the heliopause is located in your kitchen or bathroom. Turn on the tap and take a look at the place where the water hits the bottom of the sink. The area where the water is flowing along the surface of the sink is interstellar space. The place where the water disperses due to the impact is the heliosphere. The thin border where the falling water runs into the flowing water is the heliopause. Scientists divide the heliopause into a bow shock, the place where interstellar space scatters about it, and the main shock wave where the solar wind is slowed down by the impact of interstellar space. What does the heliopause look like? Thanks to the traveling probes, we know much more about it now, but still not enough. Voyager 1 and Voyager 2 crossed the heliopause at different points, located a different distance away from Earth. It showed that the resistance was different at varying exit points, as well as other conditions. And here's another bit of nuance. For a long time, Voyager 1 couldn't even definitely prove to the scientists that it had crossed that border. Where are we as we fly through space with our heliosphere? We are within an interstellar cloud. Around us, several similar clouds right now. We are approaching the edge of our native cloud. It is throughout its existence within this cloud that it became the solar system as we know it. In 3,000 years, we will exist in new conditions in the so-called G cloud. It won't happen anytime soon, though. Because even with our speed of traveling through the galaxy, there's still a huge distance we must cover to leave our native interstellar cloud. Who knows, perhaps in a few thousand years, it is not only our appearance that would change. By then, the solar system may be much less habitable. The actual crossing of the heliopause by the Voyagers has been a subject of many arguments. It's no joke. NASA announced that the Voyager 1 crossed the border between the solar system and the great cosmos only on the September 12, 2013. That's 13 months after the discovery of the fact and rigorous checking of this information. The probe had actually crossed the heliosphere on the August 25, 2012. So how did they know that it happened? The experiment showed that the very hot particles present in the solar wind are gone. On the contrary, the cosmic radiation, the traces of the influence of surrounding star systems, extinct stars, our recent neighbors, had increased. However, many researchers were not convinced about these findings, and they had their reasons for it. Firstly, the piece of equipment responsible for an extensive analysis of particles emitted by the Sun and other stars stopped working on Voyager 1. More precisely, it was a plasma device. Secondly, the scientists do not expect that the magnetic field beyond the constraints of the solar system would be pointed in the other direction, but that didn't happen. We still don't know why. To this day, it is unclear why the magnetic field outside of the heliosphere is the same as the magnetic field within it. But in 2012, solar storms swept through our solar system. Voyager 1 sensors recorded these changes in the space weather, and their readings proved that the probe did indeed cross the bounds of the system. As the echoes of the storms collided with the much denser environment than that in which Voyager had previously been. That is, the probe was already outside our heliospheric bubble, whereas the crossing of the heliopause by the Voyager 2 went much smoother. Its plasma device was in working order, and it registered the crossing in 2018, simultaneously confirming the data recorded by its sibling. Right now, scientists are getting more and more questions that cannot be answered. To begin with, when crossing the border, Voyager 1 transmitted absolutely unnatural data, as if it was breaking through something very dense. Moreover, the data showed that it had crossed the borders more than 5 times in a row. What was stopping it? What don't we know about the density of the heliopause? Some scientists believe this was a natural process, and the probe simply could not break through the boundary for a while. But the oddities in there, the coordinate system, according to scientists, seemed to have gone insane, so much so that it was unclear whether Voyager was moving or if it was frozen in place. That strange Reddit story told at the beginning of the video is likely based on this information. After several checks, it turned out that the probe remained operational and did not experience any additional malfunctions. Neither did it switch to safe mode. Despite the fact that the equipment continued to act crazy, the probe itself obediently carried out commands and continued to transmit signals. So what actually happened? Scientists dispelled any mysticism quite easily. They believed that since the probe was in a place it was not ever expected to visit, such malfunctions in the work of the equipment are far from the worst thing that could happen to it. But what lies behind the formal answer, we are yet to find out. Now, the probe is responding to commands from Earth, but the issues continue to this day. No one knows what happens to it there beyond the influence of solar energy. According to some of the versions, the cause of the malfunctions is the old age of the probe, or the damage sustained in the process of traveling through the heliopause. But the mystery of Voyager 1 does not end there either. Some time ago, a signal came from outer space, and it's not the friendly wow the scientists hoped for in the 1970s. The signal is a low-frequency humming sound transmitted by the sensors of the Voyager 1. The nature of this sound is yet to be unraveled. The most common explanation is that the sound is the amalgamation of various vibrations of interstellar space. After all, Voyager is now slicing through space at hypersonic speeds. Some scientists believe that this signal happens in connection with the so-called foam effect. When moving, the plasma and interstellar matter crash into the heliopause and turn into a kind of foam, similar to sea foam, from the waves hitting the shore. But where is the truth? Until now, neither astrophysicists nor other scientists have a clear answer to this question. After all, their knowledge is limited by Voyager 1. But everything indicates that Voyager 1 will still have time to surprise us with new discoveries on the other side of the border. Right now, both probes continue to transmit information about interstellar space. They measure the electron density by registering radio waves produced by solar flares. These eruptions are expected to become more frequent as the sunspot cycle peaks in 2025. The current data shows that the density of interstellar space has increased even compared to the space immediately after the heliopause. Although logic suggests it should decrease because the border has already been crossed. Strange, isn't it? What are the Voyager probes up to next? Voyager 2, which still has a working plasma device, will monitor the temperature of interstellar matter. Most likely, this temperature will decrease. Astronomers expect it will go as low as 7,500 Kelvin. However, it is still unclear what the data will show. The ultimate goal now for these twin probes is to take a sample of the untouched interstellar medium, a space so far removed that the heliosphere has little to no effect on it. For now, we wish the Voyagers to stay warm as long as possible, and delight us with new discoveries. Foreign